Hello, it's Mr. DeCrane doing some examples about finding limits. Hopefully you've done the practice problems that come before this and tried them first. And here's some solutions and how to do these. So let's start out with this particular function. This is the graph of y equals f of x. And so the limit as x goes to negative infinity on f of x. Let's see, as x goes to the left all the way off, that graph appears to be going down. So that's going to be negative infinity. F of negative 6 is the value of the function at negative 6. And that's going to be that point right there, so that's 0. But the limit as we get close to negative 6, both sides, the left and the right side, are going up to infinity, so that limit is infinity. F of negative 2, let's see, oh, there's an asymptote here, but that point is the value of the function, so f of negative 2 is going to be 6. The limit as x goes to negative 2 from the left means I'm coming down this way and getting closer and closer there. So that limit is 6. The limit as x goes to negative 2 from the right, that's what that little plus sign means. Remember, from the right, it's heading down this way. So that limit is going to be negative infinity. So what this means is that the limit as x gets close to negative 2 on f of x does not exist because the left limit and the right limit are not the same. The limit as x gets close to 0, well, the function is continuous at 0 when x equals 0, and so I don't have to worry about it there. This is just going to be 5. It's the same as the value of the function when the function is continuous. The limit of the function as x goes to 5, let's see, as x goes to 5, the limit, oh, there's a hole in the graph there, so I know that f of 5 is going to be up there at 15, but the limit as x gets close to 5 is going to be here at 10 because that's where the function, the y value of the function, is getting to. And then finally, the limit as x goes to infinity on f of x. Even though this is wiggling around, there is actually an asymptote right there at at y equals 0. The limit as it goes to infinity is 0. Even though it's wiggling around, the end behavior is it's getting closer and closer to the x-axis, so that limit is 0. Remember, you can cross horizontal asymptotes as many times as you want. You just get closer and closer to it as you go on to infinity. All right, here we go. Second problem. If we're going to evaluate limits using rational functions, it's often a good idea to rewrite this. So I'm going to factor it completely. G of x is equal to x squared plus 2x minus 15 factors into x plus 5 times x minus 3 times x plus 1 over 5 times x squared minus 9. Ooh, that factors some more. X squared minus 9 is x plus 3 times x minus 3. Oh, and look, the x minus 3's divide out to 1, so g of x is equal to x plus 5 times x plus 1 divided by 5 times x plus 3, provided x is not equal to 3. Because remember, this version exists, it's continuous at x equals 3 because there's no hole, but this one does not. So we have to get rid of that part of the domain on there. So the limit as x goes to negative infinity, well, let's see, I have to think about this one for a minute. Yeah, so I'm going to go back to the original function. If I multiply this out, my numerator would be x cubed plus some other stuff. My denominator is 5x squared plus some other stuff. The numerator is going to get bigger a lot faster. And that's going to be negative because negative infinity, a negative number cubed is negative. So this is going to be negative infinity. The limit as x goes to negative 5. Well, the function's continuous at negative 5. Negative 5 makes the numerator 0, but it's in the denominator is okay. So that's just going to be 0. The limit as x goes to negative 3. So there's a problem. We've got an asymptote there. So at, or let's say near, negative 3 from the left, negative 3 plus 5 is positive, negative 3 plus 1 is negative. The denominator is 5 times negative 3 from the left is more negative. So if I add 3 on, I'm still going to be negative. So it's a negative divided by negative, which is positive. So that's going to be positive infinity. And from the right, negative 3 from the right, I've got negative 3 plus 5 again is going to be positive. Negative 3, something close to negative 3 plus 1 is still negative 5. And something